Energy systems. Aerobic system. 2 energy systems: aerobic and anaerobic. An energy system which is used in prolonged continuous activity in the presence of oxygen and does not produce lactic acid. Anaerobic. Energy systems that do not rely on the immediate use of oxygen. There are 2 types of anaerobic energy systems. 3 metabolic pathways: anaerobic lactic, ATP-CP, or ATP-PC. Anaerobic lactic, glycolysis. Aerobic, cellular respiration. A slow-twitch muscle energy system which is used in prolonged continuous activity in the presence of oxygen and does not produce lactic acid. The aerobic system, long-term energy. Exercise performed at a level relies almost exclusively on the aerobic system for energy production and requires the athlete to use as its source of energy. Most daily activities use energy provided by the aerobic energy system. The is the most important energy system in the body. While this pathway cannot generate the speed of the anaerobic, it does provide a great deal more Formula. Key nutrients. Remember your fats, proteins and carbs because they are crucial for the fuel for the aerobic system. The aerobic system, cellular respiration. The aerobic system energy requires the metabolism of proteins, glucose, glycogen, fats, oxygen, combined to produce ADP plus PATP. Energy. CO2. Water. Using energy produces. Cellular respiration involves 3 separate pathways: glycolysis, Krebs cycle, electron transport chain. Subpathways: cellular respiration, glycolysis. First stage. Same as anaerobic lactic system, see previous lesson. Where glycolysis changes with the aerobic systems. In the presence of oxygen, is converted to coenzyme. Rather than No lactic acid produced with aerobic at this time. Acetyl-CoA then enters a more complicated pathway known as the Krebs cycle. Central pathway for the metabolism of and Series of reactions. ATP molecules are produced at this stage, along with new compounds capable of storing high energy electrons are sent to a process within the known as the electron transport chain. During the final stage of aerobic respiration, are produced. Electrons pass down the chain. Highly reactive molecules, free radicals, are byproducts. These molecules may be a contributor to long-term muscle fatigue. ATP-produced energy system: ATP glycolysis Krebs cycle. Electron transport chain. Total aerobic power, Vo2 max oxygen uptake. The power of the aerobic system is generally evaluated by measuring the maximum volume of oxygen that can be consumed in a given amount of time. This can be measured by determining the amount of oxygen exhaled as compared to the amount inhaled. As the intensity of work increases, the capacity of the aerobic system reaches a maximum. You can only breathe in and out so much. The greatest rate at which oxygen, volume, can be taken in and used during exercise is referred to or aerobic power Vo2 max. Each person has his or her own maximum rate of oxygen consumption, Vo2 max. A normal Vo2 max for most high school athletes would fall somewhere between the Vo2 max values of trained athletes will reach. The more active we are, the higher the Vo2 max will be in that range. The effect of training on the aerobic system. A person's ability to perform an activity is limited by their maximum rate of oxygen consumption, Vo2 max. The most efficient method for improving the aerobic energy system is endurance training/exercise. Long, slow distance training or exercise at the low end of your underscore tends to use slow twitch, ST, fibers. SD fibers are slower to fatigue and are well suited for endurance activities. The effect of training on the aerobic system. Endurance exercise consists of: generally, the higher the intensity, the greater the oxygen consumption. When exercising, the target heart rate, THR, should be raised to 70% of max. Finding your target heart rate. The effect of training on the aerobic system coned. Examples include running, swimming or biking for 40 minutes or more at a heart rate of 130 to 140 bpm. Note, a highly trained or elite athlete should be able to sustain a heart rate of 85% of their Vo2 max. This type of training does not raise your anaerobic threshold. Endurance training has 4 major effects on the aerobic system. Characteristics of the aerobic system. The oxygen system is highly efficient. When oxygen is used in muscle cells, it prevents the buildup of underscore. An individual can work out longer before underscore. It is able to remove lactic acid from muscles, allowing the muscle to continue to contract, allowing exercise to continue. It promotes underscore of ATP for energy when work output is low. Characteristics of the aerobic system. As the duration of activity increases, the contribution of the aerobic system to the total energy requirement increases. Due to this, there are 2 limitations to the aerobic system. Using the systems together. While running at a comfortable pace, you use both systems, but the anaerobic-aerobic ratio is low enough that the lactate generated is easily removed, and doesn't build up. As the pace is increased, eventually a point is reached where the production of lactate, by the anaerobic system, is greater than its removal, anaerobic threshold. Note, depending upon the distance and effort, the body can use different proportions of both of these systems. For example, the 800 meters race is too long to be a sprint, but too short to be a distance race. Therefore, it is run at the crossover between the aerobic and anaerobic systems. Training the systems together. The best method to train all of the systems together is underscore. Interval work consists of repeating a series of short, high-intensity runs alternating with rest, recovery, periods. Whichever method is used, the athlete must continually push themselves into a lactate-burdened state, which makes their body adapt. Regardless of the race distance you are training for, 5K or marathon, interval work will help you run faster. Summary: the energy systems. Energy for muscular activity depends on a supply of ATP that can be broken down into ADP and phosphate. All of the body's biochemical processes and the 3 energy systems require ATP. Trained individuals are able to use ATP and remove lactic acid more efficiently than untrained individuals. Roles of the 3 energy systems in competitive sport. Anaerobic pathways. Aerobic pathways. Primary energy source. Energy system. Fuel. Duration. Sport event. When the systems are used. ATP, CP system. When the systems are used. Glycolytic system. Aerobic system. Feel the burn.